So let's understand this problem situation diagrammatically. Here I have constructed a right triangle indicating the positions of the balloon, ground, and the motorcycle. So here we see that the position B represents the initial position of the balloon. That is, it is at a height of 130 feet above the ground. And after 6 seconds, it has gone to position B prime. That is, it is moving at a rate of, in fact, we say that it is moving at a speed of 9 feet per second vertically above. And at the same time, the motorcycle is traveling horizontally, that is towards the right, at a speed of 88 feet per second. So which is indicated by M, where M is the position of the motorcycle after 6 seconds. And in this situation, we have to determine the rate at which the distance between the balloon, that is B prime, and the motorcycle changes. So basically, we have to determine the dz over dt, which is used to determine the rate at which the distance between the balloon and motorcycle changes. So our first step is to calculate the distance z using the information. Here I have represented GB prime, which is the distance between the balloon as well as the ground after 6 seconds, and GM, which is the distance between the ground and the motorcycle position after 6 seconds, and MB prime is the distance between the balloon and the motorcycle after 6 seconds. So we have to calculate X, Y, Z after 6 seconds. So GB prime, let's calculate Y first, that is GB prime, and this equals GB plus BB prime. We know that the distance GB is 130 feet, so we put 130 plus BB prime, which is basically the distance the traveled by the balloon after 6 seconds. Since the speed is 9 feet per second, we say that the distance traveled equal to speed times the time, that is 6 seconds. So we put the speed equal to 9 feet per second, and after 6 seconds we have to calculate, so we put the time as 6. So therefore we can calculate this equals 130 plus 54, and this gives 184 feet. Now let's calculate GM, which is the distance traveled by the motorcycle after 6 seconds. Here we simply put the speed, which is 88 feet per second. This is the speed of the motorcycle times the time. The time is 6 seconds, so we multiply by 6. So this gives 88 times 6 is 528 feet. So this is the distance traveled by the balloon. I'm sorry, by the motorcycle after 6 seconds. Now, using these two information, that is the distance traveled by the balloon after 6 seconds and the distance traveled by the motorcycle after 6 seconds, we can calculate the corresponding distance between the motorcycle and the balloon. So for this, we can apply the Pythagorean theorem in the triangle, that is in the bigger triangle GMP prime. So here we see that the square of the legs, that is a GM square, plus GB prime square, this equal hypotenuse square, that is MB prime square. So we will substitute this value. We know that GM equals 528 feet. So I put 528 square plus GB, we calculated as 184 feet. So we plug in 184 quantity square, and this equals MB prime quantity square, or we can say that this equals z square. We now calculate z using this equation. So therefore, from this equation, z equals square root of 528 square plus 184 square. And when we plug this into the calculator, we get the value of z as 559 feet. So this is the distance between the balloon and the motorcycle after 6 seconds. We now find the rate of change of distance between the balloon and the motorcycle. For this, I'm going to set up the equation using the Pythagorean identity. Since we know that GM equals X and GB prime equal Y and MB prime equal to Z, we can write down the Pythagorean identity for this triangle. That is, we can write down as x squared plus y squared equals z squared. We now go ahead and find the derivative of each of the variable with respect to time. So the derivative of x squared with respect to time is, first we have to apply the power rule. So therefore this becomes 2x times, and then using the chain rule we differentiate only the x. When we do that, we get dx over dt plus, once again we find the derivative of y squared with respect to time. So first we apply the power rule, which gives us 2y, and then multiply with the derivative of y with respect to time, that is dy over dt, and this equals, similarly this becomes 2z times dz over dt. Now we can see that we cancel the 2, we have 2 on both sides, so I just cancel it. We now plug in the values, that is we have x dx over dt. We have all the information such that we have to find only the dz over dt. So I'm going to substitute each of the values. We found x equals, which is gm, which is 528 feet. So maybe I can mark this is equal to y and this equal to x. So x equal 528 feet. So I substitute 528 times of dx over dt is the speed of the motorcycle, which is 88 feet per second. So you can put 88 without the units, plus y equals 184 feet. So we put 184 times of y dy over dt, which is the speed of the balloon, and that is 9 feet per second. So I simply put 9, and this equals z times of dz over dt. So we just calculated the z, which is 559 feet. So we plug in 559 times of dz over dt, and we can solve from this dz. We can solve dz by dt from this equation. So therefore dz over dt, and this equals, we plug this into the calculator. That is, we multiply these two and add with this quantity, and finally we divide by 559, and when we do that we get the value as 86.1 feet per second. So this is the rate of change of distance between the balloon and the motorcycle.